In this video, we'll talk about case statements, which is how you do conditionals in SQL, as well as functions. Alright, so what is a case statement? Well, a case statement is a lot like a switch statement in C++. It's basically you say, here are a bunch of different conditions, and what do you do under each case or under each condition? So the way that this looks is, as a case statement, it's a lot like an insert into statement, a select statement, create table statement. It is a statement in SQL. It starts with the keyword case, and then you say when something is true, like when grade is less than 2, then set status equal to failing. So when a particular variable is less than something, set another variable to another value. Or when grade is less than 3.5, then set status to passing, else set status to rocking. So else is the catch-all if none of the previous when statements fire. And then at the end, you just say end case to denote you're done with the case statement. So once again, what are case statements used for? They're used for conditional expressions. They're used for when you want to do things like if and else, or if one of these many conditions is true. And so there's always two forms to case statements. Now, one form is the one that's shown above, and it tests when a when statement evaluates to true, and then the then clause is executed. The other form of a case statement is this. You say case and then a particular variable, and then you say when failing. Now, what does that mean? It says when status equals failing, then you set come talk to equal to 1. When status is equal to passing, then set come talk equal to 0, else set come talk equal to 0. So this allows you to evaluate, basically it's an easier way of writing the previous one when you just need to test for equality. So once again, this is a way of, they're both case statements, they both work very similarly, they just have slightly different forms depending on what's more useful. If you just need to test equality, this form of the case statement is a lot easier to read, but if you need to do more complicated Boolean logic, then the other type of case statement is more useful. Alright, so these are case statements. How do you know it's a case statement? Well, it starts with case and ends with a semicolon. Another way to use the keyword case is in expressions. These are things that return a value. So you can use case as an expression in some other SQL statement. So if I say I want to set the column come talk in a particular table named students, I could say update students set come talk equal to, and then I use this case statement to figure out what I should be setting come talk to. So I could say case when grade is less than 2.0, then do 1, and then set come talk to 1. Then when grade is greater than 4.0, then 2, else 0, end case, semicolon, and then there's a close semicolon for the update. Now, forgetting where those semicolons can go can be tricky. I won't really ever ask you to write case statements in this class, but I just wanted to let you know that they exist. In reality, if you need to write case statements in your SQL code, you're probably doing something wrong. Really, this sort of programmatic thinking should probably be done in a different language, and that different language should then provide the new and improved values to SQL using things like update and insert statements instead of trying to do it in SQL logic. But there are times when you have to work in SQL instead. Okay, so the alternate form, just like there's two forms of case statements, there's two forms of case expressions, is when you say case status when passing, which says, when status equals passing is basically the same thing as the example before. Once again, this is a case expression because it's in some larger statement. Okay, so one very important rule when you're working about these is to realize that you can only use case statements in stored procedures. All right. Variables are another place that you use generally only within stored procedures. However, case expressions you can use anywhere that you would use a value, anywhere that you would need a particular string or particular number or a particular column set to a particular value. And unfortunately, SQLite only supports case expressions, not case statements. So, where are you allowed to use variables and case statements? So, the correct answer here is only in stored procedures. And this is kind of a trick question because, once again, I haven't talked to you about what triggers are yet. That will come later in the videos for this week. And I will also completely accept the last answer. You could use them anywhere you want. They just may not work. Okay, so that is case statements. We really won't be talking any more about them in this class. They're not going to come up in homeworks or exams. They're primarily there just so that you know that they exist. Some people use them more. I feel, and many other people feel, that case statements are things that should be avoided at almost all costs, because it's really not the point of the database to be doing this sort of logic. It's really much more the point of the application, and the other people using the database should transform the data there and then tell the database what the data should be. But once again, this is part of the SQL language. I wanted to at least touch on it before we move on. Okay, and what are we moving on to? We're moving on to functions. Now, we've seen a number of functions before. We've seen the count function, we've seen the max function, we've seen date time related functions. And so what are functions? They take 0 or more arguments, and then they return one result, one thing. And there's a lot of functions defined in SQLite. You will not ever need to memorize them, though they may come up on homeworks and you may have to look up, oh gosh, what is the function that gives me the absolute value of a number, and look it up in the SQLite documentation and see it's ABS, and it takes some column and it returns the absolute value of its argument. Or it takes a copy, lower takes a string and returns a copy of it in lowercase, or upper returns it in uppercase, or random returns a random signed 64-bit integer, and type of tells you the type of the thing that you passed in. Or round, which takes 2 arguments here, returns a floating point value rounded to so many digits after the decimal point. Or trim takes in a string and removes so many characters from each end. All of these are nice functions in SQL. However, there are times when there's a function that you would love to have in SQL, but it's not built in there by default. So what do? Well, instead of cry, you make a user-defined function. So this is for when you want to add a custom function, a function that you write, and you put your little special bugs that only you can put into your functions. So for instance, let's say we wanted to define a function called title. It takes an argument, like the string x, and returns it in title case, meaning that the first letter of each word is capitalized. So how would you do this? Well, the first thing you want to do is you want to make a function that does what you want in Python, just a normal function. You define a function called makeTitle. It takes in x as an argument, and what does it return? It returns x.title, because actually in Python, this .title method does exactly what you want. In reality, I chose this example so that it'd be really easy to show. You write some function that returns the value you care about. And then what you do is you tell your connection to the database. Remember that CONN thing that you always get from the connect function of SQLite 3, the thing that you keep calling execute on? Well, instead of calling execute on it, you call create function on it, and you pass in the name of the function, you pass in the number of arguments it takes, and then you pass in the actual function itself, which in this case was make_title. And after doing that, you can actually say execute select title bracket name. Just like this was a normal built-in function, SQLite is perfectly happy to basically say, hey, instead of using my own functions, I should use this wonderful Python function that was been provided for me. And this is a way to convert, for instance, all of the students' names into title case if they, for some reason, didn't capitalize their name correctly. All right, so once again, there's 3 parameters to the create function method on the connection object. The name, which is a string saying what should the function be called in SQL. It doesn't have to be the same name that the function is in Python. You could make a function called X and give it the SQL name Y. It just means that when you use that function in SQL, you better call it Y. The number of parameters the function requires, which in this case, most of the time it's just 1, but sometimes it needs to take multiple parameters so that you can combine data from multiple columns. You know why you might write a function that takes more than 1 argument. The other thing is you can actually overload functions with different number of arguments. I don't recommend that because it can get really confusing if people forget to provide a parameter, but it's up to you. And then the function itself, the function in Python that should be called. And the function can return any of the SQLite supported types. So it can return bytes or string or int or float and or none. Okay, so before we kind of wrap up talking about functions and stored procedures, I want to really make it clear the difference between those two. So a function must return a value. It must return something. It could be none, it could be an integer, but it must return a thing. Stored procedures don't really ever return anything. But what they do is they change one of their arguments if a stored procedure even goes as far as to do that. Functions can only have in arguments. They only can supply arguments in. They can't change the arguments that they were given. However, stored procedures can have in and in-out arguments. So if that's important, you should be using stored procedures. The last thing is that stored procedures manipulate the database directly. Stored procedures, you're allowed to use all of those other SQL statements like select, update, insert, delete, all of those things. You can use all of those within a stored procedure. Whereas functions cannot do anything with the database. They can't do their own queries. They can't check things. They can't change things. All they can do is return a value with their given inputs. This makes them a lot safer. It also makes them a lot easier to write.